This is section 6.5.1, solving linear inequalities. So we start with a review of the inequality symbols. We have less than, greater than, less than or equal to, and greater than or equal to. I'll point out the obvious here that the symbols that have the equal to part under the inequality symbol include the equal to. Next, we define a linear inequality. A linear inequality is a linear equation with an inequality symbol instead of an equal sign. You can see our example here, 0.20x plus 125 is less than or equal to 335. You can see the inequality symbol in the place of where the equal sign usually would occur in an equation. Remember that any of the four inequality symbols can be used in the inequality. Next, we're going to review graphing inequalities. We have three examples here. Let's work through all three of them. In each case, we're going to start with a number line. You always graph an inequality on a number line. When drawing your number line, it's important to include 0 because it's sort of the starting point or the middle of the number line. Obviously, to the right we have our positive numbers, and to the left we have our negative numbers. So our inequality in part A says x is less than 3. Since x is only less than 3 and not equal to 3, we go to 3 on our number line and we put an open circle. This indicates that 3 is not included in the inequality. And then, since it is less than 3, all the numbers less than 3 occur to the left. And so we draw an arrow to the left. Let's look at part B. Again, we start with our number line. Important to include 0. And our inequality in part B says x is greater than or equal to -1. So we find -1 on the number line, and since our inequality has the equal to in it, you can see right there, it has the equal to, we're going to make a closed circle, or a filled-in circle at -1. This means that -1 is included in the solution set of this graph, and since the inequality then reads x is greater than or equal to, all the numbers greater than -1 occur to the right. Finally, in part C, draw our number line. And the inequality in part C reads x is less than or equal to 3 and greater than -1. Whenever you read an inequality that looks like part C, we read the inequality from the inside out. So we always start with the x. So on the left side we have, on the right side we have x is less than or equal to 3. So let's start by graphing that. X is less than or equal to 3, so we go to 3 on the number line. It has the equal to in it, so it's a closed circle, filled in, and less than 3 would come all the way over here to the left. All right, next, we're going to read the left part of this inequality, and that reads x is greater than -1. So we go over to -1. It's greater than -1, so we have an open circle because it's not equal to, and greater than -1 would be all the numbers to the right. All right, now we have to actually come up with the graph of this inequality. So far, we've graphed the two inequalities separately, but the inequality in part C reads x is less than or equal to 3 and greater than -1. So since we're using the word and when we read this inequality, we need to look for the numbers on the number line that satisfy both inequalities at the same time. So, for example, let's pick a number here, like this. 1, 2, 3, 4, 5. That's 5 right there. 5 does satisfy x being greater than -1, but it does not satisfy x being less than or equal to 3. So 5 is an example of a number that does not satisfy the inequality. Now if we pick a number like 0, okay, so let's pick 0. 0 is greater than -1, and it is less than or equal to 3. So that number satisfies both inequalities. So what we see is the numbers that satisfy both inequalities are the numbers that are the overlapping graphs of the two inequalities. So 3 definitely satisfies both. -1 does not satisfy both, so it's an open circle there. And all the numbers in between satisfy both. So the actual graph of the inequality in part C is the blue graph that you see on the number line. Next, we're going to talk about solving linear inequalities. Solving an inequality is the process of finding the set of numbers that make the inequality a true statement. These numbers are called the solutions of the inequality, and we say that they satisfy the inequality. The set of all solutions is called the solution set of the inequality. Now it's important to point out here that an inequality has a solution set, meaning you're going to have more than one number. This is different than when you solve an equation. When you solve an equation, you usually get an answer like x equals 3. In that case, 3 is the only solution to the equation. But when you solve an inequality, you're going to get something like x is greater than 3. And so that includes numbers 4, 5, 6, 7, 8, all the way to infinity. So there is a set of numbers when solving a linear inequality. We're going to review the properties of equality because these, again, are your tools for solving equations and inequalities. You'll remember that the addition property and the subtraction property allow us to move things from one side to the other side of the equation or inequality. The multiplication and division properties allow us to isolate the variable separate from their coefficients. If at this point you don't know your properties of equality, you really need to go back to the previous lessons and understand these properties. Okay, so the procedure for solving linear inequalities is the same as the procedure for solving linear equations, with one important exception. When multiplying or dividing both sides of the inequality by a negative number, the direction of the inequality symbol is reversed. Let's take a look at two simple examples. So in our first example here, we have -3x is less than 9. To solve for x, I would divide by -3 on both sides of the inequality. On the left side, the -3's would cancel out, leaving me with just x. On the right side, 9 divided by -3 is -3. But since I divided both sides of the inequality by -3, I need to flip the inequality symbol. So what was less than is going to become greater than. So the solution set for the inequality is x is greater than -3. Let's look at our second example. X over -2 is greater than 9. To solve this inequality, we would multiply both sides of the inequality by -2. So on the right side, on the left side, our -2's cancel out, and we're left with x. On the right side, 9 times -2 is -18. But since we multiplied both sides of the inequality by a negative number, we need to flip the inequality symbol. So the solution set is x is less than negative 18. Now we're ready to solve some more complicated inequalities. In these examples, we are asked to solve the inequality and graph the solution set. So let's take a look. 4x minus 7 is greater than or equal to 5. All right, so the first thing we are going to do is, just like solving an equation, we're going to add 7 to both sides. That way I get my constants on the right side, and I can combine them. 5 plus 7 is 12. That leaves me with 4x on the left side, and I keep my inequality symbol. Next, I'm going to divide both sides by 4. The 4's will cancel out on the left, leaving me with x. I am dividing by a positive number, not a negative number, so there's no need to flip the inequality. 12 divided by 4 is 3. So there's my solution set. X is greater than or equal to 3. Now I need to graph that. And of course, as we practiced, we graph inequalities on a number line. X is greater than or equal to 3, so we go over to positive 3. It has an equal to in it, so it's a filled-in circle, and greater than 3 would be all the numbers to the right. So there's our solution and the graph of the solution. All right, here's our next example, a little more complicated. So let's solve. 6x minus 12 is greater than 8x plus 2. So we need to get our variable terms, in this case our x terms, on the same side of the inequality so that we can combine them. And then we need to get our constants on the same side of the inequality so we can combine them. All right, so we're going to use the addition and subtraction properties to do this. And I'm going to choose to subtract 6x from both sides. So these will cancel out on the left, leaving me with negative 12 is greater than 8x minus 6x is 2x plus 2. Next, I'm going to subtract 2 from both sides. That way I get my constants on the left side, and I can combine them. Negative 12 minus 2 is negative 14. Next, I'm going to divide both sides by 2. Leaving me with x on the right, and I did not divide by a negative, so I don't need to flip the inequality. Negative 14 divided by 2 is negative 7. So I have the inequality x is less than negative 7. If it would help you to rewrite it so that you could read it left to right, it would look like this. X is less than negative 7. All right, so now I have to graph this solution. Number line, 0, 1, 2, 3, 4, 5, 6, 7. X is less than negative 7, so I would have an open circle on negative 7, and less than would be all the numbers going to the left. All right, our final example, 2 times the quantity x minus 3 plus 5x is less than or equal to 8 times the quantity x minus 1. So you can see this is a more complicated inequality, but you're still simply using the properties of equality, addition and subtraction properties, multiplication and division properties, and we're also going to have to do some distribution here. So let's do it. So on the left side, we're going to have to distribute the 2 to each term in parentheses. So we get 2x minus 6. Keep the plus 5x less than or equal to, and now we need to distribute the 8 over here. 8x minus 8. Now we can start to move things around and combine like terms. Notice on the left side, we have a 2x and a positive 5x, so let's go ahead and combine those. So we get 7x minus 6 is less than or equal to 8x minus 8. All right, get my x terms together, so I'm going to subtract 7x from both sides. We get negative 6 is less than or equal to x minus 8. And then I'm going to add 8 to both sides. And I'm going to get 2 is less than or equal to x. Or I would read that as x is greater than or equal to 2. So now I'm ready to graph my solution on the number line. 0, 1, 2, 3, 4, 5, 1, 2, 3, 4. Okay. It has an equal to in it, so I go over to 2, and I have a closed circle. And x is greater than or equal to 2, so greater than is all the numbers to the right. All right, so that gives you some good examples of not just solving linear inequalities, but also graphing the solution sets. As I said, the properties of equality are the tools used to solve not just equations, but inequalities as well. And when you graph, you always graph on a number line, as you saw here. And solving an inequality is very much like solving an equation. All right, this has been section 6.5.1, Solving Linear Inequalities.